In this lesson, we're going to solve equations with variables, but the variables could be in the denominator. So we still have fractions with the numerator and a denominator, so we are still going to clear the fraction. So we have to find common denominators, but if the denominator has a variable in it, it makes it just a little bit more tricky. And since there is a variable in the denominator, we have to check restrictions, okay? So let's do a little warm up here. We're just going to find some common denominators. So 1/4 and 1/3, that least common denominator would be 3 times 4, which is 12. Over here, 1/2x plus 1/x squared, that least common denominator would be, in terms of the number, the common denominator would be 2, and the common variable would be x squared. In this case, we have 1/a and 1/a plus 2. I'm going to add parentheses. So my least common denominator is going to be a times a plus 2. I'll just multiply them the same way I multiplied 3 times 4. And down here I have x minus 2 and x plus 5 as my denominators. So my least common denominator is, I'm going to multiply them, x minus 2 times x plus 5. So it's a slightly more complicated denominator, but it still works. And then my last one, 1/x squared minus 16, 1/x plus 4. Not too sure what my denominator should be, so let me look at the factors here. Let's break this out into, this is a difference of squares, x plus 4 times x minus 4. And this one already has the x plus 4, so my common denominator is just going to be x plus 4 times x minus 4. Because if I multiply this by x minus 4, I get my other side, so that makes my common denominator. So now I'm going to use those types of common denominators, and I'm going to solve some equations. So here's my first equation. 3/x minus 1/4 is equal to 1/12. So the first thing I'm going to do is find my least common denominator. My least common denominator for numbers would be 4 and 12 would be 12 is the common denominator if it was just 4 and 12. And I have a variable, so I have to include that. So I'm going to multiply everything by 12x. So what I'll do is multiply 12x here, 12x here, and 12x here. And I want to see what things will cancel. So in this case, x and x will cancel, so I'm left with 3 times 12, which is 36. In this case, 1/4 times 12x becomes 3, so I have minus 3x. And then I have 12 and 12 cancels out, so that just equals x. So that's a much easier equation to solve. I'm going to add 3x to both sides, and I get 36 is equal to 4x. So x would be 36 divided by 4, which is 9. Now, I do have to check my restrictions. I have a variable in the denominator. So x is in my denominator here. So one of the things I have to notice is x cannot equal 0, okay? Well, when we solved it, we got x is equal to 9, so it's definitely not 0. So we're okay with that as our solution. So let's go down and do another one. I have 6/5y minus 2/2y is equal to 1/4. So I need to find my least common denominator. So let's look at my numbers, 5, 2, and 4. Well, a common denominator there would be 20. And since I have a y, I need to also include a y as part of my denominator. So I'm going to multiply each of my terms by 20y. So let me write it out here. 20y, I'll put it over 1, times 6/5y minus 20y over 1 times 2/2y is equal to 20y times 1/4. So let's see what cancels here. Y and y cancel. 5 and 20, that gives me a 4. So this becomes 4 times 6. Then over here, y and y cancels. 2 and 20 become 10. So this is minus 10 times 2. And 4 and 20 cancel to give me 5, so that equals 5y. So now I have 4 times 6 is 24 minus 20. is equal to 5y. 24 minus 20 is 4, is equal to 5y. So y is equal to 4 over 5. Now I have to check my restrictions again. So let's go back up here. I have 5y, 2y at my denominator. So my denominator cannot have a 0 in it, so y cannot equal 0. And I got y is equal to 4/5, so it's not 0. So that is a solution that can work. Let's do another one. Now in this equation, I have 2 minus x over 3 minus x is equal to 4 over 9. If you notice, I really have one fraction on one side, one on the other. I only have these two fractions. And so what I can do, since I only have two terms here, I can cross multiply. So I can say 9 times 2 minus x, 4 times 3 minus x, and I can use that to solve it. So we're going to multiply 9 times 2 minus x, that's this side, is going to be equal to 4 times 3 minus x. And cross multiplying will only work when I have basically two fractions, one fraction on either side. Okay, so 9 times 2 is 18 minus 9x is equal to 12 minus 4x. And then I'm going to solve this. I'm going to just do my inverse operations, add 9x to both sides. So I have 18 is equal to 12 plus 5x. And then I'm going to subtract 12 on both sides. And I get 6 is equal to 5x. And then I could solve for that, divide both sides by 5. I get x is equal to 6 over 5. Now, when I get x is equal to 6 over 5, I need to check my restrictions. So if you notice in my two denominators, I have 3 minus x and I have 9. Well, 9 is a fine number in the denominator. But 3 minus x cannot be 0. So if I add x to both sides, 3 cannot be x. So x cannot be 3. Well, I have x is equal to 6 over 5. It's definitely not 3, so that works and I can use that. So let's do one more. In my denominators here, I have x plus 1, I have x, and I have 2. So my least common denominator, I'm going to have to multiply all of those. 2x times x plus 1. So I'm going to have to multiply each of my terms by that expression. So I have 2x times x plus 1 times my first term, which is x over x plus 1, and I'm going to add those parentheses to keep that denominator together, plus 2x x plus 1 times x plus 1 over x, that's my second piece, and that equals 2x x plus 1 times 5 over 2. Okay, so I have a big long equation here, and I'm going to have to cancel out what I can. So in this one, the denominator is x plus 1. Here's 1 here, x plus 1. What I'm left with is 2 times x, so that's 2x squared. Here, my x's cancel out, and I'm left with 2 on the outside, so this cancels out. And I have x plus 1 times x plus 1. And over here I have the 2's cancel out, and I'm left with 5, x plus 1. Okay, so again, it's fairly long, but we're just going to do our normal operations, and we're going to multiply. We're going to multiply by FOIL here, multiply by the distributive property here. So I have 2x squared plus, when I multiply that, x plus 1 times x plus 1, I get x squared plus 2x plus 1 times 2, okay? And I'm going to multiply that out, so that is 2x squared plus 4x plus 2, okay? So that's that second piece right here, okay? And that equals 5x times x is 5x squared. 5x times 1 is 5x, okay? So now I have to put together all my like terms. I'm going to do inverse operation, so I have a lot to do yet. So 2x squared and 2x squared is 4x squared. And I have 4x plus 2, okay? And that equals 5x squared plus 5x. Now I'm going to subtract 4x squared on both sides. And I get 4x plus 2 is equal to, this is x squared plus 5x. I'm going to subtract 4x, subtract 2. I'll do that kind of at the same time. Minus 4x minus 2. So I have 0 is equal to x squared, and this becomes plus x minus 2. So now I can solve this by saying factoring. Let's factor this. This is x minus 1, and this is x plus 2 is equal to 0. So now when I look at that, I have that x can be equal to either 1 or negative 2. So those would be my two answers. Now I need to check what I'm not allowed to have. So let's go back up here. If I look at this first denominator, that cannot be 0. So x plus 1 cannot be 0. So x cannot be equal to negative 1. Oops, sorry, negative 1. And in this case, x cannot be equal to 0. So I have in my answer here 1 and negative 2. So neither one of those are my restrictions, so they're both good answers. Okay, so the last one had a lot of steps to it, but again, we're going to follow by clearing the fraction by multiplying every term by the least common denominator, and we do have to kind of go through all the steps, whether it's multiplying or factoring. We're going to have to do all of these steps in order to get down to an equation where we can solve, and we're solving this by factoring. And we always check the restrictions. Okay, let's do some practice.